All right, we're back at it, giving you another video here. Hopefully the camera will be nice. Okay, so what we're going to do is just continue our discussion and demonstrations about relationship between the sun and the earth. And what I'm going to do a little bit more of today is get into stargazing terms. So those first few videos, it's probably nothing you didn't already know, hopefully from different times in elementary school and middle school when you're learning about seasons and stuff. But today I'm going to talk a little bit more about the relationship between the sun and the earth and the constellations, the celestial sphere, how it's based on those particular relationships. All right. But hopefully you remember from the previous videos that the plane that the earth and the sun make, that line that connects the two, is called the ecliptic, and every planet in the solar system lies on that plane. So if you were to see, Venus, it would be on this same straight line. So would Mercury, in any given planet, depending on, where it's at in its orbit, doesn't matter. It's going to stay on that same plane. That plane is called the ecliptic. And if you can tell, around the classroom, I went ahead and labeled it ecliptic, and you can see the sun lies on that line because I made sure of it. Because if you were to see the sun, I promise it will be on the ecliptic. And if something else eclipses the sun, well, now you know why it's called the ecliptic. All right. So what I just try to do is show you again throughout the classroom where that ecliptic line is. You can see it in the background right there. The planet Earth sure as heck lies on that ecliptic. And you keep going around, there's the front of the classroom there, that horizontal line. Boom. And you can see the reflection of the sun right there on the ecliptic. Did that on purpose. All right. All right. Now, for the planet Earth, itself, just geographically, remember we talked a little bit about this before. The planet Earth has what's called a prime meridian, which goes right through Greenwich, England, and straight down here. You can tell that's the continent of Africa, and that is 0 in terms of longitude, telling you how far east-west you are. You also know the planet Earth has an equator, which is right there. That again is the 0 latitude mark. That tells you how far north-south you are on the planet Earth. That's easy. What I want you to realize, though, is, or remind you of, is that equator is tilted. Okay? What I'm going to do is, well, you guys all know how tilted is it, 22.5 degrees. What I could do is project this line, the equator of the planet Earth, just extend it outward into the sky indefinitely, infinitely, forever, and it would trace out a line in the sky the same way the ecliptic does. The difference being is that line that is the equator of the Earth would not be in the same plane as the ecliptic, because the ecliptic would be, or is, right there. As you can see, this meter stick is parallel with that dark line back there. That's the ecliptic. But it looks about yay, doesn't it? So what that means is if I were to do the same thing I did with the ecliptic line, and that is trace out where the celestial equator is, then over there, back where you see that kind of funny looking, that's a beard I associate with Mickey Mouse for different classes. It's just kind of funny. But can you tell that celestial equator is going to intersect the ecliptic line somewhere back there? So if I were to put the celestial equator and project it outwards onto the sky, I would have it intersect somewhere over there, probably a little next, that's a pencil sharpener, somewhere over there. So what I'm going to do is draw the celestial equator over here. It would look something like that, and maybe right there is where they intersect. Okay, boom. So this I will label the celestial equator. Okay? And what you would then need to realize is if I were to continue that line all through the classroom, it would go way up above. And if I were to point to this chalkboard over here, whiteboard over here, you wouldn't be able to see the celestial equator because it would be higher up on the ceiling somewhere, and they won't let me draw on the ceiling. And then that celestial equator would come back down and it would intersect the ecliptic over there somewhere. Because if you remember from a previous video, this is where I had the planet Earth. And if you can't see, then the equator is right there. So our celestial equator now is coming down and going below our ecliptic for this particular part of the journey. So what I'll do is on this whiteboard, I will draw the celestial equator coming down and once again intersecting the ecliptic over here. All right, so it's going to end up looking something like that, and it intersects right there. So this blue line is the celestial equator intersecting the ecliptic. All right, so then that celestial equator would then go down and it would go onto the floor and then it would come back up over there. So this orientation, all right, of the celestial equator is what I want you guys to kind of visualize in your head, okay? The celestial equator and the ecliptic and their relationship to each other. All right, and so the reason I bring that up is because those relationships have a lot to do with all sorts of stuff. First of all, it is the basis of a grid system in the sky to tell us the location of stars, planets, constellations, whatever. You guys all know what I reminded you on planet Earth is it has a prime meridian and an equator, and they intersect right there. That's 0 latitude, that's 0 longitude. So that would be kind of the basis of a grid system, a coordinate plane, those Cartesian coordinates you learned about in algebra class in 6th grade. And, you know, positive on the equator is that way, or positive on an axis is to the right, negative is to the left, positive on a y is up, negative is down. And based on a grid system, you can locate any given city on the planet Earth. It's really that simple. What I'd like you to do is be able to envision this. What if I took this globe and I made it clear, transparent, and I got rid of all of the continents, but what I left on that clear, transparent globe is all of the latitude and longitude lines. So I have very dark latitude, longitude lines on a transparent sphere made out of plastic, clear glass, or whatever. And what if I put this light bulb as the sun inside it and I projected the latitude and longitude lines out onto the ceiling, the walls, the floor of this room? You would see a grid system in the sky. And that's exactly what there is in terms of identifying locations of where stars and planets are. There's a grid system in the sky. It mimics latitude, longitude. The only difference is we don't call it latitude and longitude. We do obviously refer to something called the celestial equator. That is the basis or the boundary, you know, between north, south. So, you know, on the planet Earth, you know, we have the equator. If you are north of the equator, you have positive latitudes. Where I happen to be is Cincinnati, Ohio. Boom, right there. We're ish. It ain't perfect. 40. It's like 39 something degrees north latitude. All right. So positive 39 is what we would say is my latitude. they would just write plus 39. That distinguishes it from negative 39, which would be in the southern hemisphere somewhere. But yeah, down there, yeah, it'd be the southern parts there of Australia. But there's 30, kind of middle of Australia there. So negative 30, you're going to be right around there somewhere-ish. The very southern part of South Africa, dancing around in Chile and Argentina. But anyway, positive, negative. Same thing in the sky, all right? The only difference is it's based on the celestial equator rather than the Earth's equator. And if you remember, I tried to draw it over there. You see the darker blue line that is tilted, labeled CE. Okay, so we're going to go above and below the celestial equator. So it's a little tilted, but that's okay. All you got to do is just remember above it or below it. And the term we use in astronomy that kind of takes the place of latitude up in the sky, how far north or south are you from the celestial equator? We call declination. All right, please remember that word. Declination is how far north or south you are from the celestial equator. So you can have a positive declination, means you're above it, north of it. Negative declination means you're south of it. Okay, and it's just a number of degrees, the same way it is on planet Earth, a number of degrees. All right, now, another thing I want to remind you of, or what I said earlier, is there's a prime meridian on planet Earth that tells you how far east-west you are from something. And a lot of students think, well, it would make sense to just project the prime meridian out onto the celestial sphere and then start from there. However, I want to remind you of something. Astronomy and astronomical observations have been happening ever since human beings started to look up. All right, so we're talking thousands of years here. People have been looking up. The prime meridian didn't come into existence, at least formally, until 1800s-ish. So astronomy is much, much older and has been around a heck of a lot longer than time zones. Okay, so we're not going to use the prime meridian as the basis for east-west locations in the celestial sphere. All right, we're not going to do that. What we're going to use is one very, very special location in the sky. And what you can see again here, I guess the line is fairly dim, I'm sorry, but the blue line for the celestial equator intersects the ecliptic at that dot right there. I made that dot pretty heavy. It was easier to visualize when I showed it to you over here. You can see it a little more easily on that whiteboard. This location and that location, they never change. These are fixed, okay? This spot and the spot over there where the celestial equator intersects the ecliptic, those locations stay fixed. Now it changes what constellations they're in, whatever. But this location here is what we will use as the basis for how far east-west you are from something. That's going to be the 0 mark. That will coincide, if you will, with longitude lines. So this will be 0 longitude. And you remember a term from a previous video, something called a meridian line. And that's if I were to take my zenith, go straight up, which is what zenith is, draw a line in the sky from north to south, that's my meridian line. Well, this location is a meridian line. So if I were to draw something like that right there, something like that is along that line, we can tell, okay, as that line moves across the sky, this is going to be what determines what your what's called right ascension is. So if I were to look straight up at any given time at night, I'm looking at my zenith, which lies along my meridian. But you know, as the time goes by, the Earth rotates, and you hopefully remember the direction that the Earth rotates is viewed from above, that goes counterclockwise. So the folks on planet Earth are going to be rotating that way, which means everything on the whiteboards appears to rotate the opposite direction. So if I'm looking straight up and I'm looking at that location on the sky, all I got to do is wait a few hours and something else will be directly above me, right? And I can wait a few more hours and something else will be directly above me, will be on my meridian or at my zenith. So the way they measure how far away items are from that line on an east-west type of plane is something called right ascension. All right, right ascension. It's a two-word term. And it's basically measured in degrees, the same way it is on planet Earth, but they don't communicate it in degrees. They communicate it in hours. And remember, an angle is made up of degrees, right? But you have minutes and hours worth of an angle, because what we said earlier is time zones on the planet Earth, right? There's 360 degrees in a circle, and 1 hour occupies 15 of those degrees. So they talk about right ascension in terms of hours, which is basically how many hours will it take for something else to rotate directly above you in the sky. Loosely speaking, it's a loose definition. So the terms that correspond to latitude and longitude, at least in a celestial situation, are right ascension. That corresponds to longitude. Basically, east-west is communicated in hours. It goes from 0 to 24.